All right, and we are live. So I'm going to do the little clap sync thing, not sync thing the app, but we do this for audio post production.
There you go.
We're so happy to record! Yay! Okay, let's get this ball rolling. Do I have my chat window? I do. Okay. Hello and welcome back to Enterprise Linux Security. We're at episode 115. So it's amazing how many episodes we've done so far. Anyway, I'm here with my good friend, as always, Joao. How you doing?
All good. As always, a pleasure being here with you, Jay. And today, because sometimes people complain that we don't specifically talk about Linux or specifically about Linux security, that's all you're going to get.
Yeah, that's all you're going to get. So we're going to be talking about Red Hat Enterprise Linux 10, which was just released. And like we were kind of talking about this before we hit the record button, I remember very early in my Linux career when I was still green, I was using Red Hat back then was not the same thing as it is now. It was Red Hat back then is what Fedora is now. It was a desktop release, obviously server as well, but I remember using Red Hat 9, not Enterprise Linux, but just Red Hat 9. And then the beta came out for Red Hat 10. And I think there was a second beta. And then at the last minute, they renamed it to Fedora Core 1. They just changed the name. And then we didn't have Red Hat as we had it back then. But then after that, Red Hat Enterprise Linux took the torch and continued along. And we've been, Red Hat Enterprise Linux has been a thing, a really big thing ever since then.
With lots of changes around along the way.
Yeah.
Yeah, but today we're discussing Red Hat 10. It was announced yesterday as of the time of we're doing this recording. We're going to focus specifically on a couple of security features that they disclosed yesterday that are on the release notes. The importance here being that you might not be running RHEL directly, but you'll be running a derivative distribution or some other distribution in that ecosystem, or even some other distribution that's not in any way related to RHEL, but will still take some pointers from RHEL. And if they see a good idea, they might as well just copy it.
Mm-hmm.
So yeah, this is going to focus on RHEL release notes, but it's also relevant to anybody else that's running Enterprise Linux in some way.
It's relevant.
It's relevant.
I had to. So when I look at through the release notes, there's quite a bit. I mean, we're not going to be able to talk about each and every single aspect of this release because there's quite a bit. Like Joao said, we'll focus on the security side of things, and also to Joao's point, it's interesting when the new version of RHEL comes out because if you use Alma Linux, Rocky, or something else, I mean, this might be a preview of what you'll be getting. Now, obviously, some of these things may or may not make it into the derivatives, but it's really fun to get a taste of what's coming. And enterprise Linux distributions, as we know, each release sticks around for a long time, probably far longer than it needs to. People don't always do a good job of updating, but we'll be using or being involved with RHEL 10 for a considerable amount of time to come. So it's a good idea to just see what's in the pipeline.
One of the first changes, and it immediately jumps when you're looking at the release notes, is about the post-quantum cryptography algorithms. This sounds like mumbo jumbo. It's not. This is really important, and you're going to be seeing this on all the Linux distributions going forward. So NIST approved a few algorithms in 2024, late last year. There was a contest around which algorithms were going to be announced as being quantum resistant. And the idea here being that there is a very critical aspect of security with how we store and communicate data around, which is we encrypt it using RSA or elliptic curve cryptography. But the thing is, it's very secure for the computing that we use and that we rely on right now. Quantum computers are a different beast. We still are not at the point where we have quantum computers able to break every single encrypted data out there. But as quantum computers are evolving quickly, we will get there eventually. We're all very good at making predictions in IT. 640 kilobytes are enough for everybody, or so they said. But the thing here is that this isn't just a theoretical problem. There's threat actors, there's malicious actors out there, intelligence agencies, probably lump them all together at this point, which are essentially just hoarding all the data that they can siphon anywhere, be it communications, being stored data, being encrypted messages, whatever they can get their hands on, they will just store it. The idea being, we don't immediately need whatever is encrypted here, but we want to be able to look at it, say in 3 years, 5 years, 10 years time, and it will still be relevant. Think about stuff like intellectual property, scientific research, infrastructure detail plans, all that kind of information will be useful regardless if it's right now or if it's a few years down the line. So NIST saw the problem with this. This is actually a problem that has been identified for a few years now, but we have only now come up with a set of standard encryption methods and algorithms that we can use that we believe are quantum resistant. So think about RSA, for example. It's essentially based on two very large prime numbers that are essentially really, really tricky to guess and to brute force if you're doing it using traditional computing. You will take thousands, if not billions of years to be able to find the right numbers, to be able to break a single message. It's expected that quantum computing will be able to shorten that period of time to just a few minutes or just a few hours, which is completely bonkers. There is this very famous algorithm by an American mathematician called Peter Shor. He came out with this algorithm in 1994, and it's called Shor's algorithm. If you're interested in how this works, Google Shor's algorithm and you'll find it. SHOR algorithm, and you'll find this pretty easily. So the idea being that using some of the weird stuff with quantum, you'll be able to try all the... Everybody has heard about fast Fourier transforms. You might not know what it is, but it's the essential algorithm behind stuff like, say, MP3 encoding. It's what enables data to be encoded to really tiny amounts. There's this thing called quantum Fourier transforms, which essentially underpins Shor's algorithm. Shor's algorithm is a way to use that, to leverage that, to break existing prime numbers and to be able to factor these numbers in such a way that essentially it's as if it wasn't even encrypted. You'll get encrypted data, you'll pass it through that, it spits out the numbers, and you just get access to the data immediately. The algorithms that we are talking about right now have these weird names like Crystals Kyber and Crystals Dilithium and Falcon and Sphinx Plus. This is stuff used for key establishment, for digital signatures, and you'll be hearing a lot more about them in the coming years as this gets more widely adopted. RHEL is one of the first OSs to come out with these out of the box. You could get them online, you could get libraries for this if you wanted for some time now, but essentially having these out of the box means that you can configure OpenSSH, HTTPD, you can configure your own services to rely on this and to be able to accept and communicate using these encryption mechanisms. The idea being, if a threat actor is looking at the traffic and has some way of capturing that traffic, regardless of using quantum computing or not, it won't be able to access the data.
Wow.
However early you decide to apply this type of encryption to your data, the better, because it means that there's less opportunity for somebody to copy that data even if it's encrypted. Remember that most of the ransomware attacks right now, they focus on exfiltrating data. So even if they get encrypted data, they are hoping that they will be able to decrypt it at some point. If you're encrypting it with these algorithms, then you're probably safe until somebody else has some bright idea. The threat model here is called harvest now, decrypt later. We know for a fact since Snowden's leaks a few years ago that the NSA, for example, has entire buildings with entire storage racks running all the time, just siphoning all the data that they can get their hands on. So we know this is a threat. We know this is happening and has been happening for quite some time now.
Yeah, that's definitely how it works. It's, and the idea is you may not be able to have the horsepower to encrypt it right now, but you might as well save it because someday, we're definitely going to be able to your point, that things only get more powerful and that just makes it easier eventually.
One of the things that you should be focusing on, especially if you have very large deployments where you'll be deploying RHEL 10 or whatever derivative you're focusing on, is trying out how your systems handle these types of connections. The encryption algorithms themselves are more computationally intensive, meaning that they will be able to sustain less load than you do right now with simpler algorithms. So you might have to adjust your workloads, or you might have to adjust your expectations on how many connections you accept, for example, if you're using encryption. It will also consume more power because it's doing more calculations. So again, if you have an especially large deployment, this is a good thing to test early so that you know and measure your necessities and be able to adjust in time. Another thing, and this is something that's going to touch on security and that it's going to touch on the day-to-day operations if you're running this type of systems, is called, it's actually something that has been around for a few years, but no OS has adopted it like this. If you've ever heard of bootc, it's a package that you can deploy right now. And essentially what bootc does, it lets you boot an OS that's running completely inside of a container. Typically, containers will run with the kernel that's running on the host. It's exactly the same kernel that's visible inside each container. It's the one on the host. There's only one kernel. bootc kind of throws a wrench in the system here. And bootc enables you to boot a system from a kernel that's contained inside of a container image. This is a roundabout way of saying that Red Hat now offers the ability to do an image deployment, meaning that you have your bare metal system, you have your clean VM, and you want to deploy RHEL there. If you opt for this image deployment, what happens is that you will essentially deploy bootc and then a RHEL image, and bootc will boot from whatever is inside that image. That might not seem like much of a difference right now, but the idea is that you stop updating individual packages inside of that image and you will only update the entire image. Meaning that if you need to update your stack, you simply pull an updated image like you do with a regular container today. And you're going to be doing that at the OS level.
Wow.
This affects everything from your monitoring, your deployment scripts. If you're running Ansible, then you don't really need to configure the system because it comes pre-built from the image. You can create the images from scratch yourself, but you're more than likely going to be running pre-built images from some repository out there, exactly like you do for regular containers right now. You can create them from scratch, but everybody is lazy. So if I have a container out there somewhere that has Tomcat properly configured, I'm just going to pull that container and deploy my application on top of it and call it a day. The less I touch Tomcat, the better. This time you're going to be doing that system-wide. So yeah, it's different from containers in that, and to be honest, I'm not entirely sure how they managed to handle this, since the kernel is supposed to exist at the host and be shared with each container. Right now, the kernel is shipped inside of the container image. So there's that major difference running there.
Yeah, immutable is really taking off, especially, and being able to deploy the entire system just as a one-off. Yeah, I'm actually kind of surprised it hasn't progressed even further, but this is a big development. I mean, this will definitely push that forward, I think.
You will no longer have to do your DNF updates because you'll simply recreate the image, the OS image, and get the new updated version of everything that's in there. That's massive. That's a massive change. And RHEL coming out with the deployment option that covers that, that's really something that we haven't seen before.
Yeah, considering how much I've dealt with dependency hell with Red Hat, and that, during my career, being able to just have an image that has everything in it and is generated based on the specification and deployed as one thing. Obviously they'll probably still find a way to have dependency hell. I hope not, but honestly, no. I mean, that's a really good feature, and it's only going to get even more advanced from here. At some point, this is immutable is going to be on everything. I could totally see it.
And another reason why you're going to be seeing this more is that bootc is not even something that Red Hat created just for this. bootc is available on GitHub. You can pull the package, you can deploy it on whatever system you want. and get it to run on whatever you're running. So it's not just a RHEL thing that RHEL has adopted it as it has right now. That's the big change, not bootc itself. bootc has been around for some time. This enables stuff like, okay, I have this bare metal system here, and now I want to run it on the cloud. I no longer have to go through all of this migration process, because we know that while we can have our application stacks running on containers and lots of VMs supporting our services, there are still systems that we're still running bare metal on our own infrastructure that we're never going to migrate anywhere else. And having those systems configured like this means that it's just as easy to ship them to the cloud or to another data center or to inside the VM. It just makes things easier like that.
Yeah, definitely.
This also addresses another problem, specifically related to security. You no longer have to go in and fix security problems. You don't have to go into a system after it's deployed or running Ansible or whatever scripts you use for that to fix configuration issues or to fix security issues or to address any problems that you're going to have. That comes from the image. So you address that when you're creating the image. You configure it exactly as you want, or you pull an image that's configured exactly as you want it to be, and that's it. You use that image. You don't have to do anything post-deployment. Exactly like a container. Everybody's familiar with containers at this point. The mindset change that you need to go from traditional application deployment to running an application inside of a container is more or less the same mindset change that you're going to have. Instead of deploying your Linux systems like you have for the past 30 years, you're going to deploy an image. And that's a considerable shift in the way that you think about your systems.
Yeah, it'd be interesting to see how other distributions take inspiration from this, and what other distros are going to try to do something. I mean, obviously, to your point, there's nothing stopping someone from using bootc right now, but usually, a lot of times we see something start in RHEL and then other distributions follow suit. So I think that this will have cascading effects on other distros.
In the chat, they're asking, how do you move your data to the new image? So the traditional approach with containers is that you have your data stored elsewhere, and you run the application inside the container, and you mount the data that's served elsewhere, your data appliance, your file server, whatever. So you won't have data stored directly inside of the container. You can have volumes, you can have local volumes, you can have mount points pointing there. I assume it's going to be something similar with this approach. Until I get hands-on experience with it, I can't exactly promise you that that's what's going to happen, but the way that they're touting it makes it look like exactly like a container. So you'll probably get the chance of mounting local storage, mounting your local volumes if you have them. Again, it's a different way to approach this. It's a different way to think about this. It gives you, for example, an option when you have an issue with the system or when you have a disaster level event that you need to recover from. You save the system creation scripts, and that's all you need. So you don't need backups from the system. You just need the script to get the system running again. Because the image is the same, you're going to be pulling the image from the cloud. It comes pre-configured, or from your own repository. In this case, it's not a repository, it's a registry, different naming there. Repositories for packages, registries for images. But the idea there, it makes it easier to stand up the infrastructure from scratch, which is quite a feat.
And that's in line with how containers are generally used. I hate to use the term best practice, but ideally in the container world, the container is disposable. The container can get deleted. You can spin off a new container from a container image and it comes back up and it just points to the data, whether it's a volume or an NFS share or something like that. Your data is going to stay where it is. It's just the application and OS layer are going to be part of the container, and then your data will still be where you left it. So, and I think it's kind of something we've always been doing, whether we realize this or not. Even early in my Linux career, before containers were even something we ever talked about, you see forum posts like putting /home on a different partition so you can wipe your distribution and reinstall it and just, mount that same partition to your home directory and all your files are there. And then later on, we have container volumes, but there's other types of things. And I'm talking about core containers right now, not Red Hat's implementation. Just the idea behind it, you have your data somewhere else, and maybe the container links to an NFS image. You can rate the container, config file. You can have your mount points listed in there, what's being mounted, whether it's a volume, NFS, or something else. There's many different types of ways to keep your storage. And to Joao's point, I would say that's probably how they're going to do it. And the reason why, again, we're not speaking definitively about this because this just came out. When something with this many changes comes out, it takes time to deploy it and to really put it through its paces. It's been less than a week. It's been a day. So we're still kind of digesting exactly what Red Hat is doing. But based on what we know of containers, it seems like the same model, but it's just being used at a bigger scale.
It also helps you in the case of compliance. When you have compliance regulations that say that your systems have to meet this and this configuration, and they can't drift from that configuration to something else. There's no way that you can have an admin that just goes in and just changes a setting and now it's running slightly different, even if it's better. This prevents that. If you're using immutable images, then that's the definition that's going to stick. If you want to change something, you change the entire system, but you won't have that odd system where some changes were applied and they weren't applied to others. If they all are running on top of the same image, then they will absolutely all be running exactly the same way. And right. that has lots of benefits when it comes to compliance. I don't want to go into the actual nitty-gritty there, but proving compliance with some standard, it's probably, you either do it properly or it's just a checkbox. And if you're trying to do it properly, then having functionality like this kind of helps your point and making your point there.
Right. And it takes human error out of the equation. To be fair, configuration management does too. But at a different layer, I mean, you think about a system where, okay, I need to deploy this system. I'll install the distribution. I'll make whatever tweaks I'm going to make. And we're all human, okay? Nobody can say they make no mistakes. They'll put a typo in there. They'll forget a semicolon somewhere, and then have to figure out why it's not working. Having a known good blessed image that fits the policies of the company already in that image, just at that point you just deploy the image and get on with your day. You just do whatever else you have to do. You're not spending so much time setting up. Obviously you have to set it up the first time and get it approved and go through a review for policy sake, compliance sake. But once you get there, then okay, this image is known good. It has all of our required tweaks inside of it already. When it's updated, you could just replace the running container with the new one. And typically what distributions do is they'll have like an A and a B image. The A image is what you're running. That's what's running right now. That's what you're on. And then when you get an updated image, it's installed parallel. Now this is the B image. So when you reboot the system, you can boot into the new image, but the original one could be swapped over. You could actually swap back over to it if something doesn't work. You have that other container that you could boot from. So you always have the A and B, which I think they're doing that, right? The release notes are so long. I'm pretty sure that's how they're doing it as well. That's standard when you have a mutable Linux distribution or Atomic. You're going to have that that secondary image. That. Yeah, thought they would.
It's going to be interesting to see how many people are going to go with, okay, I'm going to roll my own images rather than use images from a trusted registry. Because, I mean, everybody's lazy. Nobody's going to go through all the hassle of configuring everything. Red Hat actually has tools to help you with this. It's actually on the release notes as well. It's called the Insights tool. It's a tool that you use apparently to create images, and you specify the packages that you want to include. And as they tout it, and again, this is probably marketing material, so take that with a very large, healthy dose of salt. They say that with thousands of available packages, finding the right one for a specific security function has always been challenging. And the Insights tool will look at the packages that you have selected and will offer you alternatives, or will offer you additional packages that you might want to include based on what you have selected. I see that as being helpful, at least for the first time that you're going through the image building process. You'll probably remember those packages the next time around, especially in an environment where you have thousands of different packages. Most of them have weird names that are not descriptive at all. And unless you know that the package with a weird name, like, I don't know, whatever, is specifically doing whatever you want it to do, you'll never find it just based on the name. So looking at the list doesn't really help. So it's really nice if you know the package already, but if you're just staring at the large list of packages with no guidance, then it's going to be a problem. And this is particularly insidious in Linux. We're awful at selecting names. We're awful at selecting package names. I mean, the first email client that I used was called Pine. Why the hell is Pine related to email in any shape? But again, it was.
Yeah.
Kubernetes. Why does Kubernetes mean containers, or is related to containers? Again, pet peeve of mine. Having a tool that is actually smart enough, if it actually does what they say, that it's able to help you in finding alternatives or better options for whatever you're trying to do, and is able to actually identify what you're trying to do, then it can be pretty helpful, and it can be pretty handy in setting up your own images.
Man, I think a lot of us have run into this whenever we try to run an app on a distro and it tells you that it's missing a library. So you do the natural thing, right? You do apt search library name, you do, DNF search library name, and it comes up with absolutely nothing. But then you do, I think isn't it like DNF what provides off the top of my head, and then you type the library name, and then it tells you the package name that you're supposed to install. Or you just go to Stack Overflow and search for the missing library in your distro name. And you got to go through this, especially in server administration. I mean, it's one thing if you're a desktop user, just apt install Firefox, easy. But when it comes to deploying server applications, you're going to have PHP libraries. You're going to need something to connect to your MySQL database or Postgres or whatever it is. Or you roll out an app and you get everything running, or you think it's running, you check it and it's not running because it's complaining about a library, and then you got to figure that out. It's kind of what we go through, and I think that the names, then to your point, the naming of the packages is part of that problem, because if the packages were named well, I mean, it's like I'm trying to remember the name, but I had to install net-tools because I needed one of the utilities that's included in that. But you search for that utility, app search, it doesn't show up. Oh, I have to install NetTools. Who knew?
Yeah, it's guesswork. If it helps alleviate that guesswork, then it's great. If it's just going to recommend that you install PHP when you select HTTPD or Apache, then that's hardly helpful. If it actually tells you that, okay, you're picking up security tools, you might be missing a log management tool, and this is probably a good alternative. You should pick this one as well. That's very helpful if that's the case. Again, experience with this stuff is probably going to help. This comes in the release notes, so they are making a big deal about it. It's called the Insights tool. If you're going to go with the image deployment route, you'll probably be looking at some point at how to create images. You should be looking at the Insights tool as well, because it will help you with that process. Another helpful feature, and again, it had to, it's the AI assistant. So RHEL 10 has Lightspeed. Lightspeed is the name for your command line AI assistant that ships with RHEL 10. You essentially type a command, type in natural language query, and it will pop back the answer. It's exactly as if you had done that in a chatbot in a web interface, only it comes from the command line. There are other tools, terminal tools out there, connection tools out there that already offer something like this. But the way that this could be beneficial and that this could prove to be exceptionally helpful is that if it has knowledge of the entire system. If you ask him about something like, okay, I need to block the IP addresses that are showing on SSHD log and add those to the IP tables, firewall rules, or whatever firewall you're using, give me the command to do that. If it's able to manage that without you specifically having to grabbing the files for the IP addresses and creating the commands yourself, then it's very helpful. If it's going to give you just generic answers, then you need to look at the logs and pick up the IPs, and then this is the command to add one IP there. I mean, if it's that, then it's essentially just saving you a Google search.
I'm hoping that it increases SE Linux adoption, because what a constant problem in our neck of the woods is that some administrators, obviously no one in our audience, but administrators out there will deploy something and it doesn't work, and then they'll disable SE Linux and then it does work, and then their mindset is like, well, I got it working and SE Linux was getting in my way, so it keeps getting in my way, so I'm going to get rid of it. The correct way to handle SE Linux is to update the policies and to fix it so that you can keep SE Linux enabled and then still get the desired functionality. So then imagine an AI, you have an app, insert name of app here, update or show me a policy that's going to allow it to work with these particular constraints. For example, a constant one is port. Like if you have an application that listens on a particular port, we all know Apache's on port 80, Nginx and things like that. SSH is on 22. Often when you change the port to something else, it stops working, because now SE Linux is like, oh, you're supposed to be on port 22 or you're supposed to be on 80. Why are you listening on this other port? I'm going to just shut this off. But in this case, you could say, okay, AI tool or Lightspeed, weird name. I need this updated to be on this port. I want to, and then get the policy applied. And obviously, to your point, you could go on Stack Overflow and someone's probably asked that question. But in this case, I'm hoping that people will use this to keep SE Linux enabled, because SE Linux doesn't exist to annoy us. It's not like the people that developed it said, how can we annoy Linux users the most? I know, we'll come out with SE Linux. That's not how it went. It's literally for a purpose. And then when you are faced with a problem like that, especially time constraints, you got to get the server deployed by the end of the week. Then an AI tool can help with some of those edge cases that you don't even have to leave your terminal to look up information on how to solve a problem. I think it's a pretty cool feature. I'm excited for that.
I mean, if it might even be a learning tool. If you don't know a particular program specifically well, if you don't know how to do a specific task, because it's not essential to your work, if it's something that's just security related and you're just focusing on your sysadmin tasks, asking the question and getting an explanation on what to do and how it's done, that will help you learn. So that's an improvement tool for even for the sysadmins. I see that as being helpful, again, if it has proper context knowledge, if it knows, for example, what commands you're trying to run, so that you don't have to feed it the error messages. It can just look back at what happened and know, okay, the user or the admin is having issues doing this or that, and I know how to fix this, and so this is the answer that he's probably looking for. If it's able to look at files in the system and the configuration in the system, that's actually, I can see that as being very helpful. If it's just generic stuff, again, that could be solved with a Google search or just going to a chatbot yourself and doing it manually. If it's knowledge aware, if it's system aware, then I can see that as being very, very helpful.
I think a lot of people within our audience will appreciate not having to leave the terminal. It's like some of us, we live in the terminal. I got to open up this chat bot, but being able to do it right, you're already using SSH to connect to that server to manage it. You're already right there. If there's an AI tool that you could use that's installed, then it just makes it a lot easier. A lot of people might like the idea of asking AI a question, but not feel like going through the hassle of getting it installed and getting it working. But if Red Hat's taking care of that for us, then it's a tool right there at our disposal that we can use anytime we want, or we could completely ignore it if we don't want to use it, which I think is also important. But and to your point, just asking general questions like, what's the proper way to install this, or, open this port. I keep using ports as an example, but you get the idea.
Yeah. On the flip side, it's going to get some questions regarding data privacy. Where is my data going? Is this happening on the cloud or locally? What is being shared? Who has access to that? Those are all questions that are going to be important for people on the compliance side. It's going to be important in systems handling sensitive data. It's going to be important in industries that are heavily regulated about where data lives and is stored. So Red Hat really needs to come out with that that information. And it's probably better if they do it beforehand, before people start getting annoyed by that, because
Hmm.
just making sure that people are able to use it without all the concerns that come with it, that's great. I've seen
Yeah.
adoption at some companies being delayed a lot because management isn't ready to share their internal information with the chatbot that lives somewhere. There are concerns about that. So yeah, there's data privacy considerations. Um, you need to be able to trust the information that you get from it. We've all seen chatbots start to hallucinate. Hint there, hallucinate means lie. We've all seen chatbots do weird stuff. So we need to be able that it's not going to give us an answer that just RMs the entire system out of hand.
Right.
So having the ability to trust it without knowing all the commands that are out there, that's also going to be important.
I think it's actually critical because if you think about the information, like the things you ask AI in this context on the command line, how do I install this app? How do I secure that app? How do I do this? How do I do that? Even if those questions were to leak, then a threat actor can build a list of software that's used in an organization internally by just, oh, they asked about, Nginx, so they must be running it. They asked about this, they must be running that. If that information was to leak, I mean, the information would really be helpful to threat actors because they know exactly what apps to target. Obviously, they're going to try to figure out with or without AI what's being run in an organization. But if they download a list of questions, I mean, in less than a minute, they have a list of everything that the organization uses. So I agree. Red Hat does need to detail this if they haven't already, because we really need to know where the data is going to go. Because ideally, I would prefer not to have it not leave the system at all. Like it just be right there. As soon as it goes up to the cloud, like to your point, how do they secure that? And what are the secure channels? And some companies, if they were doing it in the cloud, might opt out of this feature altogether, just because not because they think there's an actual problem, but there could be one.
Yeah.
And that might make some people nervous and they might not want to implement this. And the other thing about this is communication is key. And I don't feel like the Linux community does a good job with this. For example, you had GNOME classically removing the minimize button from Windows. And it would have been a lot better if the verbiage was, oh, we took the minimize button away, but this is what the workflow is like, and this is how you manage that. But no, they just say we just took it away. Now, when it comes to this, on a bigger scale, the communication is key because people need to know where's the data going. It's one thing to say, hey, we have this feature, you should get excited about it. But then the next question, to your point, but what about the data? Where is it?
Yeah. I see this feature as being, I see Lightspeed, this particular AI feature, as being useful in a way that's related to the next thing that I'm going to be talking about. They also mentioned that they have improvements related to Podman and Quadlets. Podman is Red Hat's Docker. Quadlets are the integration between Podman and systemd. So essentially, you define the containers as a quadlet. It's a file that has the configuration for the container. And from that moment on, you're able to run that container as if it was a systemd controlled service. You have systemd, system control start, system control, all the options that you regularly have. One of the problems that I've faced over the years when using this and trying to configure this on systems is that the documentation is severely lacking behind on all the changes that happen on Quadlets. When you're looking the particular syntax on how to create a specific configuration for a Quadlet file, you'll often find documentation that is 2 or 3 or 4 versions old, and this is only talking about deprecated features. So you try to apply that, it doesn't work, then you have to track down the latest version of the documentation, and then there's another change somewhere. It's just a hassle to find the right information. If Lightspeed is able to help with that, in itself, I see value in it. But yeah,
Mm-hmm. Yeah, definitely.
finding the right information, being trained on the right information, that's crucial for this to work properly. As I was saying, there's improvements to Podman, there's improvements to Quadlet. This means that there are improvements to systemd, obviously. This integration, if you're not very familiar with it, the benefit that you get from it is that you standardize the monitoring and the management of containers in a given system. It makes life easier for your scripts. It makes life easier for your deployments. It's just a nicer way to handle things. Again, if you're not a RHEL fan, if you're not a Red Hat fan, if you're using something completely different, if you're on Debian or something else, then you'll probably have different ways of doing this and you're very happy with them. I find this to be particularly useful and particularly nice to configure. And yeah, I like it. There will be changes to this. They're working on improving this. Again, syntax improvements, syntax changes are probably going to come with new versions. So if you have your quadlets properly configured right now, you'll probably have to refine that.
Right. Maybe you'll ask AI how to refine it.
Yeah, probably that. Another thing, and this will probably be the last feature that's security focused that we're going to be covering today, it's about DNS encryption support. DNS encryption is the thing that prevents a third party from looking at the queries that are done and looking at the data that is transferred between DNS servers. And it comes out of the box. You could have configured this on Bind for many years now, provided that you find the right versions and you configure it yourself. RHEL 10 includes support for this out of the box. Why that's important is that it makes your life easier if you're trying to secure your systems. Not leaking DNS data is pretty important. It's a very big deal. You might not realize it, but the information that you're leaking when somebody is able to see your DNS queries, it's massive.
Oh yeah. I mean, just the Stack Overflow searches alone. I mean, just looking up, oh, he's on Stack Overflow or, something like that. All that information is open source intelligence. It's something that we discussed before. The more information that a threat actor can get, the better for them, the worst for us. But in this case, encrypt all the things. It's out of the box.
Yeah. So yeah, as we've covered today, there are quite a few security features that you should be taking a look at, even if you're not going to deploy RHEL. The stuff about the quantum-resistant algorithms, that's very important. You'll be hearing a lot more about those algorithms as we're moving forward. Quantum computing is not going away; it's only going to improve. So having the ability to resist algorithms running on quantum computing is very important. At some point, the requirements for essentially all the standards out there are going to require you to use one of these algorithms. You should at least deploy this on a couple of systems to see how much it increases the load for your particular necessities, how much overhead it creates for you, because you'll be encrypting your HTTP requests, you'll be encrypting your SSH with different protocols, you'll be encrypting your email servers connections. Every communication is going to be using one of these algorithms. So you should deploy it and see how much you're able to do with the current equipment that you have. It will help you, size your fleet for whatever you're planning to do better. Because again, this is not going away. RHEL coming out with this out of the box means that every single distribution is going to include them in the next version that they release. So yeah, that's a really good change. That's something that has been worked on in the cybersecurity space, and lots of other applied computing groups out there have been focusing on this for quite some time now. It's great to see this in a distribution like RHEL that has such an impact on the ecosystem. And yeah, lots of interesting and great features to be excited about.
Yeah, absolutely. And I can't wait to see how this impacts distributions like Rocky and Alma, just to see kind of how that all plays out. Because like we mentioned earlier, it starts with a big distribution like Red Hat Enterprise Linux coming out with the feature set that inspires other people. And, sometimes you have people working on multiple distributions. So it's only a matter of time before we start seeing these in other distros as well. I wonder if the next LTS Ubuntu might get some of this. That'll be interesting.
And if you have a few hours to kill and you like math in some way, Google up Shor's algorithm. Google quantum Fourier transforms. It's a rabbit hole, but it's a really interesting one.
Yeah, it's a quantum leap.
With that's our episode for today. Thank you, everybody who joined, and until the next one.
Thanks for tuning in. Appreciate you.